Michio Kaku, a really influential physicist, is discussing a wild new find. He's known for his physics smarts, and he just said that the James Webb Space Telescope discovered 6 massive galaxies. A lot of scientists didn't think these could even exist. If this is true, it could totally redo how we see the universe. It's a big deal to pay attention to. Kaku is a little too much in science. He's got both American and Japanese upbringing, and everything he does covers both regular physics stuff and quantum stuff. Unlike some scientists who are stuck in their ways, Kaku is excited about what the James Webb Telescope is showing us. It's pretty cool that he's speaking up about something we can't ignore. The excitement, which you can even hear, maybe even a little chuckle, at what he's referring to, the find made by the telescope, he thinks this is huge, and it really makes you think. So let's talk about Kaku. He thinks about these 6 big galaxies. He's always been open to new science ideas. He knows that Einstein's ideas and the inaccuracies in Newton's laws show that everything in space is changing. The James Webb Telescope could really change things in science, even if some other experts aren't so sure. This has made some viewers of the Big Bang Theory a little worried, as well as some quantum mechanics fans, but Kaku finds it funny. The JWST demonstrated these 6 enormous galaxies from super early in the universe. They have more stars than our Milky Way, even though they showed up only 200 to 700 million years after the Big Bang. The astronomers are calling them universe breakers because finding them messes with what we thought we knew about space. Something's not adding up. The Big Bang Theory says that the universe was a mess right after it started. It should have taken ages for things to form, and then even longer to become dense enough to emit a lot of light. Things like galaxies ought to have come a long way later. However, these new galaxies are enormous, some even bigger than the Milky Way. Because they are so bright, they were probably making a lot of stars way faster than we do. Researchers aren't even sure if we know when the first galaxies appeared. For now, it seems like it was just single stars or little groups, and they slowly came together into dwarf galaxies. These tiny galaxies collided with one another, making bigger ones. According to old ideas, big galaxies couldn't have existed that early. So, does this mean the universe is much older than we believed? Or did galaxies form way earlier than we thought they could? Some old-school scientists are unhappy since this is the case. It's difficult to reconcile. Some areas of physics refuse to accept this discovery, questioning the age calculations. Kaku recognizes that and declares that some old, wrong ideas stick around due to the fact that some scientists' well-known ideas only get proved wrong after experiments demonstrate their failure. Kaku declares that science, particularly physics, needs people doing experiments to keep the idea people honest. We don't really know a lot about the origins of the universe. From the 1927 Big Bang Theory, seeing that the universe is spreading out that made people think everything started from one spot. Back then, it was difficult to imagine the universe having a beginning and an end. The idea of the universe's infinity was too much. Even now, scientists have trouble with this. We should remember these things. Once more of these new discoveries contradict. For years, scientists have hypothesized based on the Big Bang, but science has demonstrated over and over that we need to rethink ideas and be open to trying new things, to progress, which requires regularly monitoring theories in comparison to what we see. In Einstein's time, people thought stars and planets remained in one location. We now know that everything is moving. Planets go around stars. Stars move in galaxies at hundreds of kilometers per second, and galaxies move fast in space. Where they'll end up, we don't know why. Scientists are shocked. Scientists are beginning to realize that certain facts aren't quite accurate, and that theories are just guesses until we test them. The Big Bang Theory came from seeing galaxies move away from each other. The farther they are, the faster they are receding. This is known as Hubble's law. From Earth, things like cosmic background radiation and the far-off redshift of light supported this, but we have to remember that people who thought the Earth was flat and that everything went around it thought they had proof too. We're in the same spot today until better things come along. Scientists wanted the James Webb Space Telescope to prove the Big Bang was correct, but these 6 galaxies that break the rules remind us that science keeps going and that scientists have to be open to new finds. The need to rethink old ideas is clear. Redshift is used by researchers to determine cosmic stuff. Redshift, or the Doppler effect, is when the color of light changes. If you remain still and hear a car approaching, the noise gets louder. When it goes away, the sound changes. It's the same thing with light. When a star moves closer, its light goes blue. When the star moves away, it dims and turns red. This is called redshift. Physicists use redshift to figure out speed and distance in space, but even small mistakes can cause big problems. The measuring stuff we've been using is now being looked at. It'll be interesting to see what researchers find. We need to consider if the universe is being calculated wrongly. In contrast to the fact that scientists are refusing to accept the facts, it is necessary here to take a deep look and re-examine the data that's been used. The recent progress in space reminds us that science has to be new and flexible. Materials can tamper with old beliefs and ideas. The James Webb Space Telescope's big find of 6 galaxies demonstrates that we must continue to reconsider things as we learn about space. We have to remember that it might be way more complex than we anticipated. The galaxies the telescope found, which are way older than we thought, might mean we have to redo a lot of stuff we've believed for a long time. This isn't just a small thing, it's a turning point in science. Scientists like Kaku say we do not know everything about the universe. Every new discovery adds to the story. Some scientists don't like these new discoveries, but that's expected. Doubt frequently surrounds major scientific advances from those who are used to thinking a certain way. But as Kaku also points out, the past is full of new discoveries and experiments that have altered our perspectives. We thought we were aware of being adaptable, and new stuff is what helps us learn and figure out the universe. These new finds are important because they don't just challenge old ideas. They might also help us find new ways to learn. For example, figuring out how these big galaxies formed so early might change how we think galaxies form. It might also make us change our ideas about how the universe has changed, like how fast stars take shape and grow in galaxies. Michio Kaku's expertise breaks down the way he sees it, which is really important. He's willing to be open to new ideas, no matter how crazy they sound. He knows the James Webb Space Telescope is significant, and it demonstrates that scientists are starting to be more flexible when they discover new information. Scientists have always made use of testing and data to make guesses, but sometimes the data leads us to new places that make us question what scientists proved wrong in the end. People like Kaku remind us that learning never stops. We're always finding new things that might alter our perception of the universe. New telescopes, better tools, or new ideas. Learning about the universe is far from done. These recent finds are probably just the start of an exciting new astrophysics chapter. As we keep learning, we have to remember that science is a process. It's driven by curiosity, doubt, and trying really hard to discover the truth. The James Webb Space Telescope's finds aren't just from a few, but from a large number of employed individuals in order to decipher the mysteries of the universe, which grows with each new piece of data. The puzzle and each find gives us a new way to see the cosmos. This is an awesome time in space exploration, and we should be enthusiastic about the universe. The questions Kaku and other scientists ask remind us that there is a great deal more to learn about these findings and see the results. These findings are crucial not only for assisting us in figuring out the universe, but also for bigger questions that scientists have been trying to consider for centuries. People have always wondered how the universe started and what it's really like. The Big Bang theory has been important in explaining how the universe came to be, but these new finds mess with that idea. The galaxies that the James Webb Space Telescope found suggest that our universe might be bigger and older than we thought. This makes us rethink everything, from how galaxies form to how our universe works. It's crucial to keep an open mind. Science is questioning, testing, and improving concepts that we previously accepted may no longer hold true as we uncover new evidence. The detection of these 6 massive, far more ancient galaxies could alter how we understand the fabric of the universe. Kaku is cool because he's open to new ideas, unlike some scientists who are stuck in their ways. He's excited about these telescope results. He believes the current theories by Einstein and Newton don't fully explain the cosmos. These galaxies are extremely ancient, dating back to the universe's early days, and they have more stars than our Milky Way. The astronomers are calling them universe breakers because they mess with everything we thought we knew. The Big Bang Theory says that, at first, the universe was I believed that the sun and earth are flat. I went all over the planet, and they also had proof. The objective of the telescope was to demonstrate the Big Bang Theory, but it turned up bizarre galaxies. This brings to mind that science is constantly evolving. Scientists use redshift to measure how far things are in space. It's like how a car sounds different when it's coming toward you as opposed to moving away. When illuminated, it turns blue when approaching and red when departing, but even minute deviations from these measurements can cause havoc. So, are these new space results due to redshift errors? Or are there scientists who are refusing to believe what they're seeing? We need to carefully examine the data to learn about the most recent space finds. These show that scientists need to be able to change their minds. New finds can challenge beliefs, and the James Webb Space Telescope findings show that this happens often. The universe might be more complex than we thought. The galaxies discovered by the telescope may indicate that we need to change many ideas we've had for a long time. This has been more than just a thing. It's a big moment in science. According to Kaku and other scientists, our understanding of the universe is not new and complete. Discoveries enrich the narrative of space exploration, but some scientists do not like these new finds. That's not new, as major scientific shifts frequently encounter questions. But Kaku says that history is full of old theories that were changed after new experiments. Being open to change is how we learn. These new finds are a big deal because they challenge old theories and could lead to new research. Studying how these galaxies formed so early could change how we think about galaxy formation. It might even change how we see the universe growing, mainly how quickly galaxies evolve and new stars form. As we get more information, we might be entering a new era in cosmology, one that challenges our preconceptions about the universe. Kaku's perspective is significant because he's ready to accept new ideas, no matter how strange. His support for the James Webb Space Telescope findings shows a shift in science toward being more open. Scientists have always relied on evidence and tests to form ideas, but sometimes the evidence leads us to unexpected places. We are reminded by the work of Kaku that learning is never done. We're always looking for new information that may alter our perception of the universe, whether through new telescopes or ideas. The search to reveal the secrets of space is far from over. These recent discoveries may signal the beginning of an exciting new chapter in space science. We must remember that science is a process driven by curiosity and a search for truth. The James Webb Space Telescope demonstrates that it is a team effort to reveal the secrets of the universe. Every new piece of data completes a bigger puzzle, and each find offers a new way to see the cosmos. This exciting time in space exploration inspires us all to remain interested in the wonders of the universe. The questions raised remind us that there is so much more to learn. As new discoveries come in, we may find out more shifts in how we perceive space and time. The search has only just started. These finds are important not just for our view of the universe, but also for the big philosophical questions that humanity has wondered about for centuries. The start, the vastness of the universe, and its true nature. The Big Bang Theory has been important in explaining the origin of the universe, but these new finds question that view. The galaxies found by the James Webb Space Telescope suggest that our universe could be far more complex and older than we once thought. This shift requires us to reconsider everything. As stated by Michio Kaku and others, it's crucial to approach these brand new discoveries with an open mind. What we once accepted may no longer hold as we uncover new proof. The questions raised by these recent events are a component of the natural process of science, and they're important for pushing the limits of knowledge. The excitement, however, is strong among those wanting to explore these things and how they affect our view of the early stages of the universe. The find is important because, as we continue with these revolutionary discoveries, the finding of these 6 old galaxies could drastically change the way we comprehend the cosmos. These discoveries are not just academic. They have real effects on the way we model our theories, how the universe is built, and even the kinds of technology we develop. If these galaxies turn out to be as old and massive as they appear, our calculations about time, space, and matter could all require updating. This affects everything from how we understand dark energy and dark matter to the timeline of when stars and planets, including Earth, might have first formed. Scientists are currently pondering new questions. Could there be other forces or principles at work in the early universe that we don't yet understand? Are our tools for measuring cosmic distances and ages flawed in ways we've overlooked? Or is it simply that our current models are too limited, built based on erroneous assumptions? Kaku believes that embracing these new possibilities is how science thrives. For him, these anomalies are not roadblocks. They're invitations to think bigger and better. He inspires aspiring scientists to see this as a moment of opportunity, not confusion. When theories are challenged, it indicates that we are getting closer to a more accurate picture of reality. In many ways, this echoes the big shifts in science from the past, when Newtonian physics couldn't explain everything and Einstein's theory of relativity changed the game. Now, maybe we are standing at the edge of another revolution in science, one that challenges the Big Bang or at least asks us to look at it differently. The James Webb Space Telescope has opened a new door, a window into the past. What it reveals might be just the beginning. If more massive galaxies from long ago are found, and they probably will be, it might form a pattern, a new narrative about the early universe. It might even change how we comprehend time itself, or our definition of the beginning of everything. For now, scientists are going back to the data. They're checking models, double-checking redshift measurements, and rethinking what is possible. Kaku emphasizes that this process is beneficial and at the core of science. Real progress only happens when we have the courage to admit what we thought was true might not be. That's how breakthroughs happen. So what does this mean for future space exploration? If a lot of galaxies existed earlier than expected, then planets and maybe even life might have had a head start. That could alter where and how we search for life in the universe, shift our expectations of what's out there and how common it could be. We may also require new missions, new instruments, and theories that can handle this complexity. People, like Kaku, are passionate right now because it's not just about 6 galaxies. It's about everything we thought we knew and what comes next. The door to a deeper universe is cracking open, and we're all watching, waiting, and pondering the next level.